For almost 100 years, we've known this one basic fact about our universe. It's getting bigger, but that is not the whole story. Not by a long shot. You can think of it like a giant loaf of raisin bread baking in an oven. As that dough rises, every raisin moves away from every other raisin. That's pretty much what galaxies are doing. But this is where the story gets really, really weird. I mean, everything we know about gravity tells us it should be hitting the cosmic brakes, right? It should be slowing this whole expansion down. For decades, astronomers just assumed they were measuring how much it was slowing down. But oh boy, the universe had a huge surprise waiting. The expansion is accelerating. Galaxies are flying away from us faster and faster, like something is pushing the gas pedal to the floor. Now, this isn't some small detail. This is a discovery that completely flipped our understanding of the universe on its head. So, what in the world is this phantom force that's pushing our universe apart? The answer would change everything. Our journey to figure this out really kicks off in the late 1990s, with a discovery so big, so profound, it would end up rewriting textbooks and winning a Nobel Prize. So, to measure these insane distances in space, astronomers needed some kind of cosmic yardstick, and they found a brilliant one. Type 1a supernovas. Think of them as cosmic light bulbs. We know exactly how bright they're supposed to be because they all explode with pretty much the same incredible brightness. So if you see one that looks kind of dim, you know it's just incredibly far away. It's a simple idea, but it's genius. And it lets astronomers look back in time and map out the entire history of the universe's expansion. And what they found, well, it was just staggering. The expectation was that in the distant past, the universe was expanding faster and gravity was slowing it down. So those ancient supernovas should have looked brighter than our models predicted. Instead, they were like faint whispers in the dark, way, way dimmer than they should have been. And there was only one possible explanation for that. Those supernovas were much farther away than anyone thought possible, which means the expansion of the universe had actually been speeding up. This wasn't just a minor error. It was a cosmic bombshell published in this landmark paper. The universe wasn't just expanding. It was accelerating headfirst into the unknown. And the race was on to figure out why. So this discovery of an accelerating universe left scientists with a massive question. What could possibly be causing it? The answer they came up with was just as mysterious as the problem itself. They called it dark energy. And let's be real, that dark part is pretty important. It basically means we have no clue what it is. It's the perfect name for something so mysterious, a force that works in the shadows of our understanding, acting like a kind of anti-gravity that fills all of space. Okay, get ready for this, because this part is just wild. This dark energy isn't some small, trivial piece of the cosmic pie. Nope, it makes up an estimated 68% of everything. Dark matter takes up another 27%. So you do the math. That means every star, every planet, every galaxy, everything you've ever seen or even heard of is less than 5% of what's actually out there. We're living on just the tip of a giant cosmic iceberg. But here's the ironic part. The best idea for what this mysterious new energy could be, well, it wasn't a new idea at all. It was actually a century-old concept that was famously thrown in the trash by its own brilliant creator. You see, way back when everyone thought the universe was static and unchanging, Albert Einstein had to add a little something to his equations to stop gravity from collapsing everything. He called it the cosmological constant. But then, when it was discovered the universe was expanding, he ditched the idea, famously calling it his biggest blunder. But, and this is an amazing twist, Einstein's so-called biggest blunder might actually be the key to solving the universe's biggest mystery. His constant perfectly describes an energy that's just part of the fabric of space itself, one that would push everything apart. Okay, before we go any further, let's clear something up that trips a lot of people up. Dark energy and dark matter might sound alike, but they are cosmic opposites, locked in this epic battle for the fate of the universe. Here's the difference in a nutshell. Dark matter pulls and dark energy pushes. It really is a cosmic tug of war. Dark matter's gravity is like the glue that pulls stuff together to build galaxies and all the structures we see. Dark energy does the exact opposite. It pushes everything apart. And as of right now, dark energy is winning. So, okay, we call it dark energy. Problem solved, right? Well, Not so fast. The discovery of dark energy didn't just answer a question. It opened up a whole Pandora's box of new puzzles that are still keeping physicists up at night. So scientists are asking, what if dark energy isn't just a simple constant? What if it's something weirder? Some theories are playing with the idea of quintessence, which is this dynamic energy field that might change over cosmic time. Others are wondering if maybe the problem isn't a new energy at all, but that our theory of gravity itself is just wrong on these massive scales. And as cool as those ideas are, they're all overshadowed by an even bigger problem, a cosmic puzzle that's really challenging our whole standard model of the universe. It's called the Hubble tension. Here's the deal. When we measure how fast the universe is expanding right now, using things like those supernovas we talked about, we get one number. But when we look way back at the light from the very early universe and calculate how fast it should be expanding today, we get a totally different number. And it's slower. This isn't just a small disagreement. It's a huge clash. And it's telling us that there's something fundamental about the universe and maybe about dark energy itself that we are just not getting. So why should any of us care about some mysterious energy or a cosmic measurement problem? Because what dark energy actually is doesn't just tell us about the past, it's going to decide the ultimate fate of our entire universe. If dark energy stays constant, we're probably headed for a big freeze, a future where the universe just gets colder, darker, and lonelier forever. But if it gets stronger, we could be looking at a big rip, a super violent end where the fabric of reality itself gets torn apart. Or, if it gets weaker, gravity could take over again, and we could have a big crunch, a cosmic reset button that might even lead to a new beginning. Based on everything we see right now, that big freeze seems to be where we're headed, a future where all the other galaxies don't just move away from us, but literally disappear from our view forever, like ships sailing over the edge of a cosmic ocean. Which brings us right back to where we started, the single most dominant force in our universe. The thing that's deciding its ultimate destiny is a complete and total mystery. You see, trying to figure out dark energy is more than just science. It's really a testament to our endless curiosity, our need to understand our place in this giant cosmos, and who knows what other amazing things we'll find along the way. Thanks for joining me on this journey to the very edge of what we know. Until next time, keep looking up.